So we already explained in the last video why arc sine of -1/2 is not 11 pi over 6 or 7 pi over 6. So just remember, those aren't in the range of arc sine. It can't output values that are not in between negative pi over 2 and pi over 2. Those are the only outputs that it can have. So that's why that's why it is. Okay, so we're going to evaluate these without a calculator. We're looking for arctan of 1. So in other words, we're asking the question, there is some angle on the unit circle, on the part of the unit circle that we use for arctangent, whose tangent is 1. So let's think about our unit circle and think about where that could be. So again, we're only using these values here. And tangent equal 1 means that it's either it's one of the 45s, right? Because root 2 over 2 divided by root 2 over 2. And it can't be this bottom one. It can't be this bottom one because that would have a negative 1, right? Because this would be negative root 2 over 2. Or it would be negative root 2 over 2 divided by positive root 2 over 2. So it's only this angle right here. So what's that angle? Well, that's pi over 4. So arc cosine equals -1. So remember, for arc cosine, let's do the same color. Okay, arc cosine only uses this part of it. And so we're asking, where is the cosine equal to -1? Well, cosine is the x value. So it's equal to 1 right here, or to -1 right there. And that's the only place, right? And that's at pi. So what angle on the part of the unit circle that we use has a cosine of -1? Well, the angle pi, okay? Because again, all of our inverse functions output angles. So when we input a value, we get out an actual angle. Okay, so arc sine equals -√3 over 2. So again, we're going to only use this part of the circle. And so we say, at what point is our inverse, or at what point is the sine of one of these angles equal to -√3 over 2? That's going to be down here. And again, we're not going to go this way around because that's not in the domain. We just have to go down. And which one is that? Well, that is negative pi over 3. All right, arc sine of 2. Now remember, what is our domain of the inverse sine and inverse cosine? Well, our domains are -1 to 1, right? Our domain, if you remember the graphs, they can only go as far left as -1 and only far right as 1. So we can't put 2 in there. We can't put 2 in there at all because it's not in the domain of these inverse functions, which means it's not an output of the sine function, meaning there's not a single angle out there that if I put it into the sine function, I'm going to get out to. There's none, right? And the question is, what angle would I put into the sine function to get out to? There's none, so it does not exist. Okay, let me find the next one. All right, we're going to use a calculator to evaluate these ones. So we just pull up our calculator. I thought I had it pulled up, so I'll just chill here for a second while we're getting the calculator pulled up. Awkward silence. So we're just going to plug them in. You just have to know how to find the arc sine button on your calculator. So arc sine is this little sine -1. So arc sine of 0.3 equals 0.30469. If you did not get that, I want you to go to mode right now, and I want you to switch it into radian mode because you got a degree measure. We don't want degree measures. We want radian measures. Always, 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 because we're in calculus. And who cares about those lousy degrees? All right, so 0.304. And if we wanted to find the arc tangent, same thing. Inverse tangent of -5 over 2. Make sure you use the negative button, not the subtraction button. You'd be surprised at how often that happens. -1.19. And we have to write the 0 on this one because we need to go to 3 decimal places. 1, 2. Without that 0, it is not at 3 decimal places, even though that decimal place is a 0. Okay? All right. So we're going to simplify these without a calculator. And your your intuition is going to tell you, well, sine and arcsine cancel each other out because they're inverse functions. And they basically do. But what you have to be careful of is that the answer still has to be a valid answer for the arcsine. Okay, so think about the fact that certain things can't come out of the arcsine. So let's start with this one. Arcsine of 3 over 2. What angle would that be? I believe it's pi over 3. It would be that angle. Okay, arcsine. And then what's the sine of pi over 3? Well, it's root 3 over 2. So we're okay there, right? Because the sine can input or output, or it can input any numbers. So it doesn't really matter. Arcsine's going to, pull out pi over 3, and we can input that into sine. So that's totally fine. Okay, arctan of 3 is going to output some angle, right? And then we're going to take the tangent of that, and the tangent has, we can put any number into it. So this one is also going to be 3. So these ones, usually when the arc inverse is inside, you usually can just cancel them out if this is something you can put into the domain. These ones are the ones where it gets a little tricky. Okay, so what is the cosine of pi over 3? So if you think about your unit circle, cosine of pi over 3 would be 1/2. So this is 1/2. And what's the arc cosine of 1/2? Well, in this case, it is pi over 3, so we're good. Okay. But what if we had gotten a number, like if we said cosine of pi over 3, what if in this case sine of 11 pi over 6? So let's think, 11 pi over 6 is down here on the unit circle, right? It's down here. It goes all the way around. And so what is the sine of 11 pi over 6? That would be -1/2, I believe. Sure, let's call it that. Yes. Anyway, I tell you to memorize the unit circle, and then when I have it, like when I'm trying to use it, I'm like, brain fart. Okay. So here I have the sine of this angle, and then I take the inverse sine of that value, -1/2, and what do I get? I get out negative pi over 6, because I can't get 11 pi over 6 out of the arcsine. I just can't. It doesn't exist. But I can get negative pi over 6 out. And so they're coterminal angles, so I can get that out. Okay, I know that was sufficiently confusing. Yeah, that's why everybody loves inverse trig functions, because they're confusing. All right, so we're going to solve this one for x. How do we undo the arcsine function? Well, we just take the sine of both sides, right? Because it's an inverse operation. So the sine and inverse let's start over. The sine and inverse sine are going to cancel each other out, and I end up with x squared minus 3 equals the sine of pi over 2. Okay, and what is the sine of pi over 2? Well, it's the y value at pi over 2, which is 1. So I have x squared minus 3 equals 1. So then I have x squared equals 4. I take the square root of both sides, and I get x equals plus or minus 2. That's that. That makes it true. All right, last one. We're going to do this one, and then the next one's going to relate to derivatives. So we'll get that on the next video. So given the arc cosine is 2 over root 5, find tangent. Ooh, okay. So let's start by drawing a triangle. We're going to draw this triangle, and it's going to have, we say this triangle is going to have a cosine of 2 over root 5. Okay, so we're going to draw our triangle in space, and our cosine of whatever this angle is going to be 2 over root 5. Okay, because that's what arc cosine means, is what angle has a cosine of 2 over root 5. So what is cosine? Cosine is opposite, not opposite, it's adjacent over hypotenuse. So that means that our adjacent is 2 and our hypotenuse is root 5. So then if we do the Pythagorean theorem, we actually find that this is equal to 1. So what's the tangent? Well, it's opposite over adjacent, which is 1/2. So again, you just draw a right triangle, fill in what you know, because we know the cosine is 2 over root 5. We can fill in what we know, and then we just find what we don't know.